All right, in this video, we're going to go ahead and cover section 1.8, combinations of functions and composite functions. This is also part of unit 1. Okay, we're almost done with this chapter. We have a definition here, an arithmetic combination, which is basically two functions, so f and g, for instance, that are combined by operations like addition, subtraction, multiplication, and division. Okay, please note that the domain of one of these combinations, so after we actually combine it, is going to be our real numbers that are in both in f and g. So when we have our new function, okay, or whatever it comes out to, the domain might be something, but for it to exist, it has to exist in f and g because that's where it kind of came from. Okay. Also note that when we divide, we also have the extra addition of, restriction that g of x can equal to 0, because if this is equal to 0, it's division by 0, which is undefined. So we always have to make sure we include that restriction for division. All right, we're going to go ahead and put a few more little, I guess, kind of formulas for you all. Is let f and g be two functions with common or overlapping domains. So either those mean the same thing. Okay. Then, okay, the sum can be defined by f plus g of x, which is just the f function plus the g function. The difference is the same thing, except now we're subtracting. The product, we are multiplying, so you would just be, most of the time we're just distributing at this point. And then the quotient, which is division. So the f function divided by the g function with the restriction that g cannot equal to 0, because again, division by 0 is undefined. So this is kind of like the notation you're going to see in this text mostly, but this is what it means. Okay, we're going to go right into an example, and you might have seen this at some point. So we have, and this is going to cover sum and differences. Given f of x is equal to 2x plus 1 and g of x is equal to x squared plus 2x minus 1, find all of this. So we're going to take this piece by piece, okay? I'm going to work on this side first, and I'm going to find f plus g of x. So first of all, we're going to write what this is equal to. So this right here, let me make sure I have, yeah. This is the same as saying f of x plus g of x. Okay, so if this is f, we're going to do this piece right here. And if this is my g function, then it's going to be that piece right here. Okay, so I'm going to go ahead and put that right here, but instead of actually writing f of x, I'm going to write what it's equal to. So 2x plus 1. So we're going to go ahead and do equals, this is for letter A, okay, 2x plus 1. I'm going to put that all in parentheses, plus g of x. So g of x, okay, is all of this over here. So x squared plus 2x minus 1. And all I'm doing here is I'm just adding these up together. So basically, this is kind of like letter A, okay? I hate to put the equal just over here on the side, but pretty much this equals this, okay? All we're going to do is pretty much combine like terms because there's really nothing we can distribute. So from here, I have, let's see, I have 2x plus 2x is 4x. I have an x squared. I'm going to put that in the front, okay? These are positive, and then I have 1 and minus 1. That's going to give me a 0, so I actually have nothing there. So it looks like f of x plus g of x is equal to this right here, x squared plus 4x. Okay. Now, if we look at the next part for letter B, this part right here, we have f plus g, and then we have a parentheses with a 2. So this means, I'm going to go ahead and write this. Let me box this one up for letter A. Okay. For letter B, I'm going to rewrite it a little bit different. This means we have f of 2 plus g of 2, okay? But it's actually easier if we just kind of plug it into what we already have. So we know that this right here is going to be the same as 2 squared plus 4 times 2. In other words, once you have this guy here, f of x plus gx, all you got to do is plug in the number into that expression. Okay, so this is going to give us 4 plus 4 times 2 is 8. 4 plus 8 is 12. And if we checked it the long way, if we actually plugged in our 2 into f, I mean, you could do it real quick. 2 times 2 is going to be 4. 4 plus 1 is 5. Okay, so you have that 5. Plug in 2 into g of x. Okay, so it's going to be 4. Let's see, plus 4, it's going to be 8. 8 minus 1 is 7. Okay, and 7 plus 5 is 12. So either way works. I personally think it's easier just to plug it into this guy because it's already there for you. Okay, let's try subtraction now. So subtraction is the same deal, except we do have a minus in the middle, which means we're going to have to distribute just a little bit. Okay, so be careful with this one because people do tend to forget. So this is going to be f of x minus g of x. Okay, same deal with the colors. So we have this minus this one. And I'm going to go ahead and put this kind of in parentheses. This is kind of an extra step because we tend to forget the parentheses, okay? So for letter A, or for letter C, I'm sorry, this is letter C, we have our f of x, which happens to be 2x plus 1, okay, minus g of x. And g of x is in parentheses. Notice I did put this one in parentheses also. It's just kind of more of a habit for me. But the one that you really want to make sure you don't forget is the second one, because you can see right here that there's already going to be some distributing going on right here. Okay, so we have to distribute that negative to everything inside there. This one just comes down, so 2x plus 1, just going to put an equal sign here, minus, so the minus changes all the signs in here. Remember, there's an imaginary 1, so negative 1 times x squared minus x squared. Negative 1 times positive 2x minus 2x. Negative 1 times negative 1 is positive 1. And you notice that this is very different from the one we had over here. Okay, but once you do that, you're pretty much almost done. You just got to combine like terms now. So we have 2x minus 2x, so there's no x's at all. We do have the negative x squared, so we can leave that guy there. And then we have 1 plus 1, which is 2. So f of, I can put it here, f of x minus g of x, kind of small, I'm out of room, is equal to this right here. Okay, last part, letter D, it's the same deal. Now we're just going to plug that 2 in. So all I have to do is plug it into here. So I'm going to go ahead and say equals negative parentheses 2 square. So I'm just getting this 2 right here and I'm plugging it into here. Plus 2, which is going to give me negative 4 plus 2, which is negative 2. So f minus g of 2 equals negative 2. And I did write this one back to the way it was written up here just to kind of show you that you can write it either way. You can do it this way or you can do it the way I did it over here. Okay. I know some of you are going to be a little confused here because we tend to forget. Remember that order of operations has us do this part first. So 2 squared is 4, and then we bring down the negative. Okay, so negative 4 plus 2 is negative 2. All right, so we're going to go ahead and do another example here. We have given f of x is equal to x squared and g of x is equal to 1 minus x. Find f times g of x and then f times g of 3. Okay, so this right here would be your multiplication. Okay, so I'll just put that on the side. We could think of it as a product because we are going to get a product from this operation here. Okay, so I'm going to go ahead and rewrite this first one. This is the same as f of x. So f of x times, okay, g of x. So all we're doing is multiplying. Okay, so g of x is going to be over here, 1 minus x, and f of x is equal to x squared. Okay, so let's go ahead and do that. We have x squared first. I'm going to put it in parentheses, times g of x, which is 1 minus x. Okay, and we're just going to distribute. In this case, x squared gets distributed to both the 1 and the negative x. Okay, so x squared times 1 is x squared. X squared times negative x is minus x cubed. So f times g of x is equal to all of this right here, x squared minus x cubed. Okay, and the good thing is now that we have this, we can find the answer for letter B right away because all we have to do is plug in that 3 into this. So it's kind of like saying, let me see, f of 3 times g of 3, okay, which would be the same as f times g of 3. Okay, so what I'm going to do is I'm going to take this function, and instead of my x's, I'm going to put a parentheses, and then inside that parentheses, I will put the 3 up here. Okay, so simple calculations. 3 squared is 9, 3 cubed is 27, 9 minus 27 is negative 18. Okay, so this is equal to that. And that's it for that one. Okay, finally, division, the last operation. We have this problem here. You go ahead and copy it real quick. And here on the side, I'm going to go ahead and write quotient, because that is what we're going to be getting when we finish dividing this. Okay, you will need a calculator for this part, for part C, so we'll make sure you have that ready. We have given f of x is equal to the square root of x, so there's f of x. Okay, I'm going to kind of put wherever f is, and g of x is equal to all this, square root of 4 minus x squared. Okay, so my g's are over here. Find letter A first. So letter A is saying we're going to divide f divided by g. Okay, so this one is f of x divided by g of x. Okay, so we just plug them in. F of x is square root of x, okay, divided by g of x, which is all this right here, square root of 4 minus x squared. And this function looks really weird. What you're going to see right now when we graph it, but algebraically, this is all we can do. We really can't cross things out anymore because this is completely different from this. This has terms inside the square root, which doesn't let us cancel anything out. So this is the answer for A. Okay, nice and easy. For the answer for B, okay, we're going to do the opposite. We're going to do G first. So G of x divided by f of x. Okay, so now we're going to flip it. So the g function goes first. So all of this, square root of 4 minus x squared divided by f, which is square root of x. And just like the problem before, we really can't do anything else at this point. So I'm just going to box this up. This is my answer for B. Okay. And finally, for C, we have some questions about the domains. It says the domains for both. Okay. So the domain for this one, I'm going to move this just a little bit over. Okay. We're going to go ahead and graph it, and then we'll write it down here. Okay. I'm just making a space for it. Same thing with this one. So let's go ahead and do that. Pay special attention to how we're going to do this because some of you are still kind of struggling with this. So here's our calculator. Okay, you want to turn it on. And if you're not already at the screen, so if you're here on the front screen, you just press y equals. Okay. Now, whenever you are putting anything with a fraction, you want to put everything on the top in parentheses, everything on the bottom in parentheses. So the first one for this one, f of x divided by g of x, we're going to have parentheses and then square root. Okay, the square root is just right here. It's where x squared is. You gotta press the yellow button and then that. Okay, and then x. Notice that the square root has its own little parentheses, so you're gonna have to close that one first. So this part takes care of the square root, and then we have to put another one to take care of the numerator part. Okay, divided by another parentheses for the bottom. okay, square root of 4 minus x squared. And we're going to close the square root and we're going to close the denominator. Okay, and that should give us our graph. It's going to look a little bit weird. You see that it's kind of small. And the reason that is because there are some restrictions here on the domain because we have some square roots. So I'm going to zoom in. And there it is. Notice that it kind of gets really close to 2 here. We don't know if it's going to actually touch 2 or not. So if you're not sure, what we can do is we can go to our table. Okay, can we know for sure? Well, let's check 0 and 2 because it looks like it's between 0 and 2. So before I do anything, I'm going to put those numbers here. I'm going to say I know that it's between 0 and 2. Now I just have to see if it actually is equal to any of those numbers. So I'm going to do my table, second graph, and that gives us our table. And you can see here that 0 is equal to 0. So 0 is going to be a bracket because there is a point there. Okay. If you scroll down, you can see that there's a bunch of errors because there's nothing on the negative side. So let's go ahead and go up to 2 and look, we also have an error. Anything after 2 is non-existent, which means that 2, going back to our graph, 2 is kind of like where the graph gets really close to. So we're going to have a parentheses on 2. Okay, let's go ahead and go back to our y equals. I'm going to clear this one. I'm going to do the second one now. So I'm going to switch it. So again, we have our parentheses for the numerator, square root 4 minus x squared, close the square root, close the numerator, divided by square root of x. So parentheses, square root x, close the square root, close the denominator. Okay, sometimes, for instance, this bottom part, you probably would not have needed an extra set of parentheses. I tend to do it just in case because this calculator is a little bit picky with how it formats some of the stuff. Okay, so let's go and graph it. And this graph does something similar, so I'm going to zoom back out. I'm going to do standard. That takes us back to the original view. So it looks like it kind of does something similar to the other one, but it's going the other direction. And it's still between 0 and 2. So let's go ahead and write that again, 0 and 2. But we don't know if it's equal to. So we're going to go ahead and look at our table again and see what's happening at 0 and at 2. Okay, so in this one, 0 is an error, which means we have a parenthesis there. It's just getting really close to it. And in this one, 2 is equal to 0. So that means at x equals 2, we have a x-intercept. Y is equal to 0. Okay, that's what I meant to say. Y equals 0. So here we do have a bracket. We do have a point there. All right, so I'm going to go ahead and move this away now. And we're just going to look at these domains. And I just want you to take note that they are, even though we did use the same functions here, because we switched them, even though domains kind of look similar, they're not necessarily going to be the same all the time. Okay, so just be really careful. Don't assume that it's 0 and 2 for, whatever, in this case, in this problem, 0 and 2 for every problem. Okay, I hope that makes sense. Just check your work is what I'm saying. Let's go ahead and move on to the next problem. We have composition of functions next. So this you saw briefly last year because it's a topic we tend to rush in Algebra 2. However, we are going to go a little bit more into it here. We have the composition of f with g is f composite g of x, okay? And this is just equal to f of g of x. So the way you read it is f composite, this little circle thing means composite, g, and then there's like a invisible of, like of x. And all we're going to really do is we're going to plug in whatever's in here into this guy. So it's kind of like function notation or evaluating a function at a given value. But now we're going to be plugging an entire function instead of just a number. So let's go ahead and look at an example to start us off. We have given f of x is equal to 2x plus 5. Okay, so this is going to be our f of x. And g of x is equal to 4x squared plus 1, find this right here. Okay, so first of all, remember that this, we're going to rewrite it just to look a little bit more, not so scary, is f parentheses g parentheses x, where in this case, g of x is the inside function, which means we're going to plug g into f. Okay, so what you do first is you copy the outside function. So f is this one. This is our outside function or outer function, if you want to think of it that way. Okay, and we're going to put the inner function inside of it because that's what the parentheses mean. So this is our inner. So let's go ahead and do that. We're going to have f parentheses. You want to put a big parentheses because you're not going to put just a number. You're going to put the entire g of x, which is all this, okay, equals, and then whatever f of x is equal to. So in this case, 2x plus 5. So 2 parentheses plus 5. So all we're doing is we're taking f, okay? So remember, this is our f, and we're going to replace all those x's with something else. And that something else is g of x. So g of x goes in here. And right now I am going through all the steps, so you can skip a few steps here if you get it. And this is going to be equal to 2 parentheses plus 5, and now we're going to plug in what g of x is actually equal to, which in this case is this over here, 4x squared plus 1. So 4x squared plus 1. Okay. For this side, we can recopy it. That's fine. But again, I'm just kind of doing all the steps here to show you where everything's coming from. So we plug in 4x squared plus 1. It looks like this. Okay. And then we just simplify. So we're going to distribute. That would be 2 times 4x squared is going to be 8x squared. 2 times 1 is 2. Bring down the 5. Combine like terms. So 8x squared, 2 plus 5 is 7. Okay. So that means that f composite g of x is equal to this 8x squared plus 7. Okay. And that's it. That's all there is to it. You take one, you plug it into the other, and you simplify as much as you can. Okay. Now the good thing is we are going to go ahead and do the same thing. Hopefully it's not as difficult. It might be a little harder actually now that I'm seeing the square on the other side over here. Okay. So what I'm going to do is I'm going to do g is going to be the outer function this time, and f is going to be the inner. So if you want to rewrite this, you have g parentheses f parentheses x. So now this guy has to go into whatever g of x is equal to. Okay, so we're going to start with g of x because that's the outer one. So g of parentheses. So I'm copying this one now. 4 parentheses square plus 1. And inside that, I'm going to go ahead and plug in my f. So f of x is going to go in here this time. Okay, we're going to rewrite it. Instead of putting the actual, the letter f of x, I'm going to put what it's equal to. In this case, it's equal to all this, 2x plus 5. And now this becomes a fun problem because we have a parentheses with more than one term and it's squared. So that whenever you see that, you should know right away I'm going to have to FOIL. Okay, so I'm going to put some room here and do a big parentheses and then put that plus 1 here. This part right here, we're going to have to FOIL. Okay, so I'm going to kind of put an extra set of parentheses here just because I think some of us are forgetting to distribute sometimes. So I want to make that very clear. Okay, 4 has to be multiplied times whatever we get right here. Okay, so I'm going to work this part out first and then I'll bring everything else down. So for the FOIL, we're going to have 2x times 2x, which is 4x squared. And then we have the outer, so 2x times 5 is 10x. Then the inner 5 times 2x is also 10x. Okay, and then 5 times 5 is 25. And I'm going to go ahead and combine this because I can combine the middle. So that would be 4x squared plus 20x plus 25. And now I'm going to go ahead and bring everything else down. That way I don't have to carry so much stuff. So I'm going to bring down the parentheses that I had in black here. Bring down the 1. Okay, I'm just bringing everything down. And bring down the 4. So this is kind of like a middle step here, kind of on the side. Okay. And now I'm going to go ahead and distribute. So 4 times everything in here. So 4 times 4 is 16. That's 16x squared. 4 times 20 is 80. So 80x. 4 times 25 is 100. And then bring down the 1. I combine like terms. We're almost done with this problem. I know it's kind of a long one. 16x squared plus 80x plus, I can combine these two. So 101. So it looks like G composite F of x is equal to all this. Kind of a long problem. Okay. Oh, there's the doorbell. Well, we won't mind that for now. Okay. And that's it for that. So you can see that these two are very different, and that is probably going to happen most of the time. Okay. The composition of one function of another flipped backwards, when we flip these, are hardly ever the same thing. Okay. Let's go ahead and do part C now. This is the last one. So this is saying f of g of -1/2. So for this one, we're doing the composite of f of g, and now we're going to plug a number into wherever that is. So this is a value of x. This is when x is equal to -1/2. Luckily for us, we already have the answer. We have, well, some of the answer. We have this up here, okay? This is f composite g. So that means all I have to do is take this -1/2 and plug it into here. Okay, so that's exactly what I'm going to do. I'm going to go ahead and rewrite this a little bit nicer. So f, and I'll do it the other way so you can see. This is another way to see it. Remember, we can rewrite this with the parentheses instead. And I'm going to take all of this and plug in -1/2. So 8 parentheses, -1/2 squared plus 7. And this is what I was plugging in. Okay, and then we just simplify. And I'm glad it's a fraction because, again, we need some practice with those fractions. So we're going to go ahead and do this part first. Whenever you have an exponent and you have a fraction inside, you have to distribute it kind of to both of them. Okay, so this is going to look like the following. We have 8 on the outside, and we still have the plus 7 over here. And then this is going to be -1 squared, and then 2 squared. So we're like distributing that little 2 on the outside. Okay, so let's see. -1 squared is -1 times -1, which is just 1. 2 squared is just 4. And that's it. Plus 7, okay, on the outside. Here we have a fraction times a whole number, an integer. Okay, so we're going to put that over 1 and multiply straight across. So 8 times 1 is equal to 8. 1 times 4 is equal to 4. Bring down the 7. We are almost done with this problem. Okay, 8 divided by 4 is 2. Bring down the 7, or bring over the 7. 2 plus 7 is 9. So f of g of -1/2 is equal to 9. Okay. One more example on this page. This is just to kind of show you how this composition stuff works in a table. Okay. So if we're doing composition, what we're doing is we're going from one function to another and then getting to a final result here at the end. So it's kind of like a little follow the I guess number or something. I don't know how to describe that part, but if x is equal to these values, okay, and g of x is equal to these values, well, if I want to find f of g of x, what you're going to do is take all of these values and plug them into that, right? So what happens is what used to be the range, okay, becomes the domain. Do we see that? Okay. And then we pop out with a new range. And this answer right here is what we were looking for in some problem. Okay, these are just some made up numbers. So if you are looking for f of g of x provided a given values of x, this is the pattern that you're following. You kind of have this middleman g of x, which will give you those output values. So the answer for this would be the same thing here. Okay, hopefully we have some examples in the homework that kind of show this a little bit better. This is what we had in the book, so I'm just trying to explain it to you how it works. Okay. All right, so we're gonna go ahead and move on. I think we are almost done. We got 2 more examples, I believe. Okay, so example number 3, finding the domain of a composite function. Okay, so now we're gonna find the domain of whatever it is that we do here. Okay, so we have these 2 functions. F of x is x squared minus 9, and g of x is equal to square root of 9 minus x squared. They look similar, so just be careful with that. Okay. Before we do anything at all, we're going to find the domain of these 2 individually, just to kind of compare things in the end. So this is f of x and this is g of x. Okay, so the domain of f of x, this is one that I'm pretty familiar with. You should be too. It is a parabola, okay, and it goes down by 9 units. So this 9 right here, remember from the section before, means that when it translated down by 9. So here on the side, I'm just going to kind of do like a tiny little graph here for f of x. It starts here at -9 and it goes up, something like that. That's what f of x looks like, okay? So the domain for that is still, however, all real numbers. So all I got to do is put -infinity to infinity. So it's everything, okay? For g of x, we have something a little bit different. This is kind of a weird looking one. It kind of looks like a half circle, okay, so to speak. So I'm going to go ahead and show it to you here on your graph. If it turns on, there we go. And we could use transformations for this as well. We could say, well, I know that it's going to be a reflection over the y-axis, okay, and it's also going to be 9 units, not 9 units, but actually 3 because it's a square root. But let me show you. Let me show you what this one looks like. It's kind of a weird one, okay? So we have the square root of 9 minus x squared. And we close the parentheses, okay? Graph it, and there's that half looking circle I told you about. Okay, so I'm going to zoom in just so you can kind of see. Zoom in, right in the center. Oh, what happens? Zoom, and then, oh, I put the wrong one, that's why. Zoom in, my bad. Okay, zoom in. So it looks like we zoomed in too much, but we know that it stopped kind of at 3. So let's look at the table real quick, just so we know what's going on at 3 and -3. So at -3, there's a 0, and then below that, there's an error. So we know that the left side is going to stop at -3, okay? The positive side is going to stop at 3. So it's between -3 and 3. We're going to double check one more time. Let me zoom back to normal, so that way we're not messing with this. So there we go. I'll just leave it there. So we saw on the table that it stops here on -3, but there is a value there. It's -3, 0, and this value is 3, 0. So my domain for g of x is going to be between -3 and 3. Okay, so we're just going to kind of hold on to that information for a bit. Okay, you'll see why in just a minute or so. Second step, we're going to go ahead and do the composition now. So this is exactly what we did on the page before, okay, where we do f composite g. So we're going to take our f, this is this guy, and this one goes first. I don't think I'm going to color code for this one just yet. So we're going to copy the f function. So parentheses square minus 9. Okay, so where that x used to be, I have a parentheses. And I'm going to go ahead and plug in this in here. So 9 minus x squared goes inside the parentheses, and it's inside a square root. Okay? So again, this is my outer in this case. And then this, in this problem, this is the inner, the blue one, the g of x. Okay? From here we can simplify this, and this simplifies quite nicely because you can see that the square root and the square are going to cancel. So I'm left with 9 minus x squared, and then bring down that 9. 9 minus 9 is 0, so I'm just left with negative x squared. So f composite g of x is equal to negative x squared. And this one you should know what that graph looks like because it's kind of like the one I did over here, except it has a negative in front. So the graph just goes, concave down. It goes this way. It's a reflection over the x-axis. So this right here would be f composite g of x. And again, if you're still having trouble with the graphs, because you can always you can graph it and take a look, okay? So let's look at the domain for this, okay? The domain for this one, if we look at just this picture here, okay? Well, we're going to say, well, it's all real numbers, right? Because it goes forever and ever and ever. The problem with this, though, however, because this problem is asking us to find the domain, okay? The domain of this. The problem with this domain is that we're saying, okay, this function exists everywhere, and yet one of the functions that's in here, g of x, only exists between negative 3, let me use that color for g of x, between negative 3 and 3. Remember, g of x was this one. So how is it that this guy can exist everywhere if one of its components only exists in the little part right here? It's not possible. So that means that we are restricted. We are restricted by the domain of g of x in this case. So our domain would actually just be this piece right here between negative 3 and 3. Okay, negative 3 and 3. So an important note to take away from this, okay, is that these guys up here, and this is why we found the domain to begin with, okay, it restricts our domain. It restricts the domain of f composite g of x. So you want to make sure you find these first because you don't want to get this, say, oh, I found the domain and it turns out to be wrong, okay? Go ahead and write this remark down. It's kind of summarizing what we just found. It says the domain of f of g is the set of all x in the domain of g. So that's pretty much what we just saw right now, that this guy is the domain of everything that was in g of x, okay? Such that g of x is in the domain of f. So we know for sure that negative 3 and 3 is also part of the domain of negative infinity to infinity. That's all that's saying right there, okay? If you're having trouble with this part right here, just let me know. These are really best taught with examples. We can do more examples if we need to in class. Okay. Last one. Decomposing a composite function. Okay. So this is exactly what it sounds like. We're going to take something apart. Okay. So we have this function, and it's just kind of a made-up one. H of x is equal to parentheses 2x plus 7 cubed equals to this right here, g of x cubed equals to f of g of x. So in calculus, there are some problems where you have to be able to do this, where you see a function and say, well, I know that that function is made up of actually two functions. So in this problem right here, we can see that the outer function, and I did outline it for us, the outer function is actually just x cubed. So the parentheses cubed is our outer, and the inner is whatever's inside. So 2x plus 7 was the inner. Okay, so this takes a little bit of practice because you do have to know, you kind of have to know your parent functions a little bit. Okay, so for instance, if this was a square, you would say this is x squared. If this was a square root, you would say f of x is the square root of x. Okay, so let's go ahead and look at an example and see if we can figure this one out. It says write the function h of x equals square root of 8 minus x over 5 as a composite of two functions. So we have to figure out how can I get two functions out of this, okay? So honestly, the best way to do this is just kind of trial and error, okay? So I do see a square root in here, okay? And I see something inside the square root. So that's gonna be my first clue here. I'm gonna say, well, I think that this square root is part of the outer because it's on the outside, right? The 5 is not inside the square root. So the 5 is probably also part of the outer function, whatever that is. And since it's underneath this, well, all of the outer stuff is probably going to be my f of x. So let's try that. So let's say f of x is equal to the square root over 5. Okay. And since this is what's inside 8 minus x, I'm going to go ahead and outline that in a different color here. I'm going to say that's my inner. So if this is my inner, that means that this replaces the x that's originally here. So I'm going to go ahead and put this as x. Okay, and I'm going to say this is my inner, question mark. Okay, we'll see. For g of x, which is the inner, or I'm sorry, yeah. Oh, no, I put this backwards. I'm sorry. This is my outer, not inner. I'm just full of mistakes today. It's Saturday. Still no whiteout. All right, so this is the outer. We think it's the outer. If this one is inside, well, then that would just be whatever's in blue. So 8 minus x. And we think this one might be the inner. Okay, so let's check this and see if it will work. If I were to do f of g of x, so f composite g of x, okay, well, and we're going to say that this is equal to h of x, some new function. Okay, we just renamed it. Well, I would take the f function, so that would be this guy right here. So square root, okay, over 5. And instead of the x, I'm going to put a parentheses in there. My g function would go on the inside, so this would get plugged into f. So 8 minus x would go right in here. And it looks like this looks really similar to what I have, except that I have those parentheses. But remember that the square root kind of acts like a parentheses. We just don't usually write it unless it's in a calculator. So this would be the same as 8 minus x over 5, which is what we wanted. Okay, now let's say you didn't get it the first time. Let's say you picked something else. Let's say we did, I don't know, I'm just going to make something up here. Let's say we had f of x and we decided, I think f of x is going to be just the square root of x. Okay, and I think, so this would be my outer, maybe. And I think that g of x is going to be, let's see, 8 minus x, and I'm going to put the 5 here too, because I know there's a 5 there, so you have to include it somewhere. So let's say this would be the inner. We don't know. Okay, we check. So f, and I'm going to write it different this time. I'm going to put the other format here. Okay, we do it like that. We're going to go ahead and copy our f function. So square root, instead of x, I'm going to plug all this in. So 8 minus x over 5. Now this kind of looks like what I had, but remember that all of this is inside the square root. So actually, I'm probably going to have to extend my square root like this so it covers everything. And this is not equal to what we wanted. This is not equal to this. Okay, very different. If this is all inside the square root, then it's all inside the square root. You can't just pull the 5 out because you feel like it. Okay, so this case would not work. And I think, guys, that is it for this one. Let me see. Yeah, next is 1.9. So that's it. If you have any questions, this is kind of an interesting section. So let me know if you have any questions, okay? Thank you.